2, come back. Proving trig identities. So these are where we have like a left and a right side, and we have to just work one side to make it look like the other side.
Do we have to write words?
It's not like where it's like, oh, this theorem and stuff, right?
Correct. So basically what this means is we can only change one side of the equation. Now, it might specify which one we have to change and manipulate, or it might not. If it doesn't, you can pick. Typically, it's the left that's getting manipulated, but if it says LHS, anybody want to guess?
Left-hand side.
Left-hand side.
I'm so smart. We already knew that, though.
What would the other one be?
Virginia goes.
RHS for right-hand side.
Say right-hand side. Say the whole thing.
Now you see why there weren't notes for this section, because that's it.
Oh, okay.
I love it when the notes are short.
I know some of the sections I go through and I'm like, why does this not have notes? And then I go look from the previous year and I'm like, because it's like 3 lines. This is ridiculous. Okay.
Like 30 seconds.
All right. Prove the algebraic identity by starting with the left-hand side expression and supplying a sequence of equivalent expressions that ends with the right-hand side expression. So basically make the left look like the right.
Okay.
Ooh,
There's just
for, like,
a lot to see to that.
for like next year, you should do a prank on the students and like make a super long notes video just for those few points.
Yeah, but see, that means that I have to spend time doing that.
Exactly.
Right, but just leave it recording. And like,
Just start walking around the room doing other
and,
stuff.
like yeah, like
Yeah, except for a lot of them don't, especially that class particularly, don't listen to it.
Yeah.
They just watch it, like the writing, and that's it. And sometimes they miss out on things.
oh,
That class would be in major trouble if I made them do code words.
Oh my gosh, I forgot about those.
Because they would never,
They would never know about it.
yeah.
If I'm being honest, I've like just watched them, but that's because I didn't feel like messing with my headphones.
It's not usually that big of a deal, but when I did those, they would never have. And the only reason that I would really even care is because they're coming in and doing them in my classroom before the bell rings.
Oh.
So the other day, the second the bell rang, I said, I need to see them. And if they weren't done, I docked points. I was like, you do these before you come to my class. Like, anyways. All right, so we need to make the left side look like the right side. Any ideas on where I should start?
Common denominator.
How would I do that?
So we multiply the one with the x by 2 over 2 and multiply the one with like 2 by x over x. I feel like they didn't leave enough space this time too.
So 2 minus x over 2x equals 2 minus x over 2x. Done.
Wow.
Love that.
Now, obviously, I think you know, we're moving into trig identities. This is just algebraically how to do it. Tell whether or not f of x equals sine of x is an identity. So basically, we're trying to see if the end result is equal to sine of x. So kind of like the last section before we get back like into this stuff. So is f of x equal to sine of x? 6. F of x is equal to tangent of x over secant of x. Ideas on where to start?
So we do the keeping and changing and flipping thing after we convert the tangent to sine over cosine and the secant to 1 over cosine.
Yep, so sine x over cosine x over 1 over cosine x. Keep, change, flip. Sine x over cosine x times cosine x, which leaves you with sine of x. So yes, that one works. or gives us the result that it was looking for. How about this one? F of x equals the cosine of x minus pi over 2.
Isn't that just like sine of x? Okay. Yeah, I wasn't 100% sure, but like, I
Yes.
had a confidence rate of
Like
like
that.
90%.
This is why you have to know your identities. 10. F of x is equal to the sine of 2x over 2.
So is that basically just the same as like 2 sine of x over 2?
No, it's on the X.
Because it would be like that. So is this equal to sine of x?
I don't think
No.
No. No solution.
so. N-O.
Negative.
Nitrogen monoxide.
What?
Zero.
Alright, now we're actually into prove the identity. So, starting with 12. Sine of x times cotangent of x plus cosine x tangent of x equals cosine x plus sine squared x. So you might remember last year when we did these, I would just basically take and draw an arrow down so that I knew not to touch that side, because it seems inevitable that people want to start trying to manipulate and move stuff from one side to the other, but we can't do that. Any suggestions on where I should maybe start first?
Make the tangent sine over cosine.
Is there anything else I can do in this step?
Do the cotangent and make it cosine over sine.
So this way now, over here, cosines cancel, right? Then when I distribute this sine through, sine times cosine over sine, the sines cancel and leave you with cosine. Plus, sine times sine is sine squared, which is equal to what I was trying to find. So I've solved it. Why are these so out of order? Let's see. (16) Tangent of x plus secant of x is equal to cosine of x over 1 minus sine of x. Suggestions? Or anything I can rewrite,
I guess
even if it
maybe-
doesn't look like we would need it.
Maybe we could turn the things into sine and cosine stuff.
So sine x over cosine x plus 1 over cosine x.
Oh. Yeah, I guess that is useful.
So sine of x plus 1 over cosine of x Now, because I know that ultimately I'm trying to get to this 1 minus sine of x, I'm going to actually flip these and write it as 1 plus sine of x. Just because I think you might see what the next step is a little easier. Now, does this look like what I'm trying to get to?
Not quite.
Not exactly yet, right?
It has some sort of resemblance.
So this is where, this year, these problems are harder than last year. Because last year, this would have been our end result. However, they want us to get to this over here. So what do I know that I'm going to need in the denominator? Ultimately.
1 minus sine of x.
Ultimately.
Sorry.
Yeah. 1 minus sine of x. Okay? So I'm going to try to multiply by 1 minus sine of x over 1 minus sine of x. Because I know I'm going to need that in the denominator, and right now I have cosine, and I see no other way I can get that. I can't just, like, flip this fraction over and call it a day. Like, it doesn't work that way. So I'm going to try that. So on the bottom, I'm going to leave it as 2 separate pieces, but on the top, what do I have there?
1 minus sine of x squared.
1 minus sine of x. Oops, sine squared of x.
Yeah, that.
Same thing. Now, what do I have on top? Cosine squared, right?
Oh, because I'm squared.
Cosine squared of x over cosine of x times 1 minus sine of x. So now what happens?
Cosine can cancel.
So I can cancel this cosine on the bottom with the squared part on the top and be left with cosine of x over 1 minus sine of x. And that's what I was trying to get to. Put a fork in it and call it done.
As long as it's not the outlet.
Yes, that is true. Although you would be done at that point.
You'd be fried.
Your hair would be like...
Yeah, my hair, I'm pretty sure it could do that even without the outlet.
Let's see. I don't have a lot of these worked, so this is going to be entertaining at times. We might try things and have some errors because who knows?
So key points, yay.
1 over 1 minus cosine of x plus 1 over 1 plus cosine of x. Well, because in the past I haven't picked like the hardest ones because there was no end goal. Like the end goal was just whatever I felt like I wanted them to be able to do. And now I have to get you prepared for an exam, so to work a variety of types. They're more inclined to not give you the end result on the exam, though, and you have to get to what they want the end result to be. But still good practice because these are a little more difficult than the ones we did in 5-1.
So, like, if on the exam you happen to get to the point where they want you to be, but you end up working.
Well, you got to think it's multiple choice.
Oh, okay.
So,
okay.
in a sense, you kind of know, but always, my recommendation is always see if you can go farther. Because what they might do is, like on this problem, where was it? Up here. Like, this could have been a stopping point, right? So they might put this as one of the answer options, but if you keep going, you might get to this. So just, I mean, I don't know. Obviously, this is the first year for the exam, so I have no idea what they're looking for and how they're going to do their multiple choice. But it might also be like one of those questions of which of these is not a potential solution.
So, like, try to work through this as far as you can.
Because, like, personally, if they hadn't told me what the end result was supposed to be here, I would have stopped here. But if you get here and you're like, well, that's not an answer option, look and think, okay, well, look at your other answer options. What is something I can maybe try to get to, potentially, and then see if you can manipulate it to actually get down to that. I don't know. We'll have to look through the book and see if they have some examples of that, but anyways. Ideas on what to do on this one?
Common denominators.
Common denominator first, so 1 plus cosine. Kind of fit there. 1 minus cosine. Anyways. Alright, so I'm going to let's go ahead and multiply this up on the bottom because it is a difference of squares. So what is the bottom going to give us?
1 minus cosine squared of x.
Okay, 1 minus cosine squared of x. Now, you're probably like, how do you decide if you're multiplying it through or if you're leaving it? Okay, part of it is me looking, because this is one I don't have worked out, so I might be entirely wrong by doing this. But part of it is me looking at multiplying it. Am I going to get another identity that I know, which I could look at, and because this is a difference of squares, I know this is now what kind of identity? Okay, so I know that this is going to turn into something else that's simpler. But I also look over here and I say, well, this doesn't have a denominator, so more than likely everything's canceling. So let me go ahead and multiply it through, and worst case, I have to go back and backtrack on that part of it. But I already know what it factors into, so I don't have to worry about it. So then the top would be 1 plus 1, and then the cosines are canceling, right? Do we see that? Because the top's just getting added together. So 1 plus cosine plus 1 minus cosine, so that's just going to be 2 on top. So we said that would be sine squared on the bottom, or we implied that. And now what does that turn into? Yeah, 2 cosecant squared of x. So the 1 over sine squared would be the cosecant squared part, but there's a 2 on top, which gives us the 2 in front. So 2 cosecant squared of x.
So with the Pythagorean identities, would it be possible for us to use those if it's not a 1?
What do you mean?
Like, rather than like 1 minus cosine squared of x, would we do it if it's 2 minus cosine squared of x?
Well, yes, but I have to show you how. So that's a good question, though, to bring up. So if you had something like 2 plus cosine squared of x, like you said, or well, that would have to be minus cosine squared of x, like that. And let's say you get to this point and you're stuck. You're like, this isn't a Pythagorean identity, but we always think Pythagorean when we see the squared term, right? So what I would do is, would you agree that 2 plus 2, or 1 plus 1 is equal to 2? Okay, so what I would do at this point is rewrite this as 1 plus 1 minus cosine squared of x to then give me 1 plus sine squared of x. And that would be how we could use that in that situation. I think we had one the other day that was like, for example, 3 minus 3 sine squared of x. I don't remember if that was in this class or if it was in the other class. Anyways, this is what happens when you do the same thing in 3 different classes. But what we can do here, because obviously this doesn't look exactly like a Pythagorean identity, but I'm thinking Pythagorean because I see something squared, I can factor out a 3 and be left with 1 minus sine squared of x times 3, which then would become 3 cosine squared of x. So that would be kind of another way that we can manipulate those formulas, and it would work with the one that's like cotangent squared, cosecant squared, all of that. The same thing would apply to those. Just the most common ones are the sine squared plus cosine squared equals 1.
That makes sense. I was like wondering if you weren't able to do it with like say 2, if both things, like if
What do you mean?
Like, for the one with 2 minus cosine squared of x, I was wondering if, like, you could only do that if they both had a 2 on them. Like, the 2, just 2, you know.
So like this?
Yeah, kind of like that.
So yeah, you can do it either way as long as you can break it up.
I feel like I remember doing a couple of those last year, like towards the end.
Yeah. I was like, I couldn't remember if it was the other day in this class we did it or if it was in their class when we did it. But because they got to this, it looked like this, and they were like, I don't know what to do. And I was like, well, isn't 2 1 plus 1? And they were like, what? Again, it's things you don't think about till you start doing them and you have one that gets to that point. But yes, that is another way we could break it up. Let's see. 24. 1 over the tangent of beta plus the tangent of beta equals the secant of beta cosecant of beta. Now again, when you're doing these problems, if you want to change them to x's or thetas or alphas or,
Ish.
you know, whatever you're feeling, that's fine. But that's how this problem was written.
Ish.
Any ideas?
Maybe we make the thing, the 1 over tangent, I guess cosine over sine, and then the tangent sine over cosine, and then we get common denominators, or is that just a little...
Okay, so
I
maybe.
guess we
So
do
let's
that.
try it. So let's first off rewrite this as cotangent of beta. Okay, right? Because 1 over tangent would be cotangent. Plus tangent. So then let's rewrite cotangent and tangent in terms of sine and cosine. So cosine beta over sine beta plus sine beta over cosine beta. Now what?
The denominators.
Get a common denominator. So cosine over cosine, sine over sine. And if you like don't feel like, unless it's like a short answer question on like your exam, which I don't think they're gonna have you showing this on an exam as a short answer question when they give you 6. I think there's other things that they're gonna want to see you do besides this. However, if that were to be the case, I would make sure that you do write out this step. But if you can just do the common denominator part in your head, like you don't need to show me that that's what's happening. So this gives me cosine squared beta plus sine squared beta over sine beta cosine beta. Now what?
Top is 1.
Top is 1, so we've got 1 over sine beta. Nope, not that. Sine beta, cosine beta. And then 1 over cosine is secant. And 1 over sine is cosecant. And the only reason I did it in that order is because that's the order they had it in. But they would be equivalent either way. But they had secant, then cosecant, so I did it that order.
How did it become 1 on top?
Sine squared plus cosine squared is 1.
I like those identities where they just equal 1.
It is pretty satisfying. Alright, I'm realizing, because like I said, I have problems in here all out of order and stuff. I'm realizing I skipped one that is similar to this in terms of having to recognize something could be written another way that I want to show you. It's not exactly this, but the concept is more or less the same. So going back to 22, sine squared fish, alpha, minus cosine squared alpha equals 1 minus 2 cosine squared alpha. Any ideas?
So I don't think that the sine minus cosine is one of those identities, so I guess we could just do like the sine one and the negative cosine one. I don't know. Let me get my notes.
Still, what am I thinking every time I see the squared?
The Pythagorean identity.
Pythagorean identities. What do I see that I'm trying to get to? Is there a sine squared in what I'm trying to get to?
No.
So let's see if I can rewrite sine squared in terms of cosine.
1 minus cosine.
Okay, so sine squared could be rewritten as 1 minus cosine squared, manipulating that identity. Just a different way than we normally manipulate it. We normally try to condense it. Right now we're expanding it. So this would become 1 minus cosine squared alpha minus cosine squared alpha. Now what do I have?
1 minus 2 cosine squared alpha.
Yep, 1 minus 2 cosine squared alpha, which is what I was trying to get to. So see, that's another way we can rewrite something. So we tend to go from the 1 minus cosine squared to say that sine squared, but sometimes we have to work the other way. All right, I have no idea by looking at it what to do on this one, but let's see if we can figure it out. I'm sure that's comforting to y'all, but we'll get there eventually. Well, I have some thoughts, but let's see if we can figure it out together. So tangent squared theta minus sine squared theta equals tangent squared theta times sine squared theta.
I guess we could. No. No, I was gonna suggest like doing the Pythagorean identities and making it like cosine and secant. And those two go together, but I don't think that would do much.
Could you make the tangent now subtract?
What were you gonna say to do with tangent?
Make it sine over cosine?
So that's my thought initially, but again, I don't know. I don't have this one written down. This one looked interesting, so I was like, let's try it. So this would be sine squared theta over cosine squared theta minus sine squared theta. So what would I need to do now?
Possibly the common denominator.
Yeah. So let's do this one by cosine squared. So I'd have sine squared theta minus sine squared theta cosine squared theta over cosine squared theta. I might have an idea now. Maybe. I don't know. Maybe not.
if
TBD.
we like factor out a sine squared theta on the top, make it like 1 minus cosine squared theta.
Let's
times
try
cosine
it.
theta.
So that would give me sine squared theta times 1 minus cosine squared theta over cosine squared theta. Now what?
Change the 1 minus cosine squared theta sine squared theta.
So we'd have sine squared theta times sine squared theta over cosine squared theta. Now what? We are in fact on the right track.
Oh.
I just checked.
So like
I know this looks weird because of the nature of how it's now written. Okay, but that it's intentional. Okay? What are we trying to get to? Kind of lost it here. Tangent squared times sine squared. Okay? So let's imagine for a second that these weren't trig functions. Okay?
substitution or something.
What if this was like 3 times 3 over 4? Would you agree that this is the same as 3 times 3 over 4?
Oh, nice.
So I could do a similar thing here and say sine squared of theta times sine squared theta over cosine squared theta. And now what do I have?
Sine squared theta times tangent squared theta.
Yep. And that's our end result. It's just flipped. I think they had tangent squared first, but it doesn't matter. It's the same thing.
I wasn't sure if we would be able to do that, but I was thinking that was really the only way we would get the answer.
Yeah. Well, when we were getting there, I was like, I should check and make sure this is right because I feel like this is like easier than I thought it was going to be, but also harder than I thought it was going to be. So I was like, let's see.
Like it was just
I'm
a
out of
little-
problems that I have worked, so I'm seeing if there's a couple more of the harder ones we can do.
Learning experience for all of us.
I want to look at. I think I know what to do on this one, but I want to see if I'm. Maybe not. Maybe I don't.
What if you just like threw one at us and let us try it on our own and see how that turned
You'd
out?
probably cry if I gave you this one that I was gonna give you.
I don't feel like crying today, so let's not. Emily's here today, right?
Yeah. All right, try. You can try this one. Sine of t over 1 plus cosine of t plus 1 plus cosine of t over sine of t equals. I'm spacing it out so you. 2 cosecant of t.
I can't get over the fact that cosine of t just looks like cost.
Yeah.
That's why I've changed them all to X.
My algebra 2 class wants to keep saying sin and cos, and I'm like, it's sine and cosine. Stop that.
What if you mentioned to take points off?
I almost did. I was like, get it right. So now it's funny. They'll say it and they'll like catch themselves. Like even when they're just working with each other. It's really funny. Gosh. I've got like an eyelash in my eye. I'm like dying. And I have mascara on, so it's like 20
Oh.
times worse.
Or when you're rubbing your eye and then all of a sudden you remember you have mascara on after you've already rubbed it and you're like, great.
Well, mine's waterproof, so it's usually pretty good. But still,
Yeah.
I get waterproof for that reason, because it happens a lot.
There's no way to manipulate it to get one less cosine, right?
I did it.
Alright, I have 5 steps. I could have done it in 3, but I wrote out a couple.
Yeah, I think I have like 6. That's because I just wrote out all of them.
Yeah, one thing I did do together, because I was like, I'm tired of writing this over and over again, but.
Probably end up with like 20.
Hey, as long as you get to the answer, it doesn't really matter how many.
Just gotta get the right answer.
They're not telling you can only have 2 steps or something usually, so.
I don't know where you want all of you. I wish that I could help you. I'm not stopping you, I'm just trying to help. Because I want you to get the proper point. Well, I do.
What's your first step?
Try to find the common denominator.
And I would not multiply the denominator through. I would not multiply it. So I would not make it sine of t plus cosine t sine t.
Oh,
I would
do
leave it
that.
separate. Then you undid it at some point.
Yeah. I just did it with like.
Wait, you wouldn't have it as what?
I would leave it as like sine of t times 1 plus cosine of t on the bottom. I wouldn't multiply the sine of t through.
I don't know how to multiply put it through, so.
Well, it would just be sine of t plus cosine t sine t.
Okay.
Like, but you would have to undo it in the end, so don't do that.
Like, I undid it in the same step that I undid the other part, though. So, like, I guess that would still take me about the same number of steps.
So this is what my first step looks like.
Okay, that's what I had.
So now, what do you see on top?
I know that we have 1 because of the sine square and the cosine square.
Yep, so that's going to give us 1 plus 1 plus 2 cosine t. This is where I said I wrote out everything. Like, I could have gone ahead and done the 1 plus 1, but I wanted to show it. So, sine squared plus cosine squared is 1. And then plus the 1 plus the 2 cosine t from up here is that step. Riley, you look
Sine
confused.
squared plus cosine squared.
Sine times sine was sine squared. And then 1 plus cosine t times 1 plus cosine t is 1 plus 2 cosine t cosine squared t, because it's a perfect square trinomial. So it would be like 1 plus x times 1 plus x. Which would be 1 plus 2x plus x squared. So then I combine the ones to make it 2 plus 2 cosine t. At that point, I factored it out to leave me with 2 times 1 plus cosine t, which canceled top and bottom to get me to my end result. This is an interesting way that they have the multiple choice questions for this section in the book. So maybe I'll give y'all some of these just so you could kind of see what it was. But the one question says, which of these is an efficient first step in proving the identity? And then it gives you out 5 different options for what your first step could be, which I think is kind of an interesting way to do it.
That just sounds odd.
And then the next one, which of the following could be an intermediate expression in a proof of the identity? So kind of like what I would do is work it out as if I was solving it by hand, ignoring the answer options, and then seeing which of the options that's listed is something that I did. So I might give you those 2 just for practice. All right, do y'all want to see the scary problem that I said, oh, no, we're not doing that?
Sure.
I'm not going to work it because
okay.
I don't actually know how to work it without looking at the back. So I have an idea, and I'll tell you what I was going to do, which I guess would technically almost work, but not exactly. So it's 40. Sine A cosine B plus cosine A sine B over cosine A cosine B minus sine A sine B equals tangent of A plus tangent of B over 1 minus tangent of A tangent of B.
Hard pass.
I feel like that's like
Is that
another
this
section.
log sine, or what's the thing?
Law of sines is for
The
triangles.
sum and difference identities.
Yes,
Yes, they are sum and difference identities, which would have been my first thought, is to rewrite them as what that would have been. So, like, the top one would have been, is that the sine one? Sine of
Yeah, that's
A
sine of
minus
plus.
B. I couldn't remember
Yeah.
which one's which.
Yeah.
So, sine of A plus B, and then on the bottom would be cosine of A plus B, I think. I don't
Bottom
know.
one's the cosine of
I never remember
plus
which.
B.
So opposite sign for cosine. And then the other one would have been tangent of A plus B. So I was like, But that would require me manipulating everything. But anyways, that was what I saw. And then I was like, that's not what they did. They did not do that. They ended up multiplying it by like 1 over cosine A cosine B or something like that. I was like, that just seems like a lot. So anyways, so yes, I'm not giving you one that difficult, and I would really doubt that they give you one that hard anyways. But if you're so inclined, you're welcome to look at my book at some point if you want to see how to do that. I don't know if all the solutions are worked out in the back of your book or not for the odd ones, but if there's something that's not and you want to just check it with my book, you're welcome to do that. Or like if you're stuck on it, obviously you can ask me, but your problems for this section, 3, 5, 7, 11, 19, 21, 29, and 35. Those should all be kind of like ones we did, but with just different trig functions, but they should work the same way. I probably am going to start 5-3 tomorrow just because, like I said, I want to get through stuff before I leave next week, so probably will plan. But you don't have to have these done until Monday.
So what?
You don't have to do have these problems done until Monday. Like, they're not going to be due tomorrow.
Oh, okay.
Just because I know there's like games tonight and stuff, and obviously these problems take a little longer. So if you have them done tomorrow, great, but they don't have to be done tomorrow.